Solar plus battery. 2.5 years of real bills. 2.5 years ago, I spent £17,435 on solar panels and a battery for my house. And today I'm going to show you exactly what that's done to my energy bills. Not estimates. Not projections from a sales rep, real bills. My actual Octopus and Otovo statements. In 2025, I imported £1,847 worth of electricity, earned £469 back from exporting, and still spent over £2,000 on gas. My total energy bill for the year, £3,500. Now, is that good? Was it worth it? Let me break it all down. So here's what I've got. 15 solar panels across 2 roof faces on my 1930s house in the southeast. That gives me 6.4 kilowatts peak, which is a decent-sized residential system. Paired with a 10 kilowatt-hour Huawei Lunar battery, a Huawei Sun 2000 inverter, and this is important, the Octopus Flux tariff. Now, quick bit of context about my house. It's a large 6-bed detached from the 1930s, with poor wall insulation. So my energy usage is higher than the average UK home. If you've got a smaller, better insulated place, your numbers will probably be better than mine. Think of my results as the conservative end. If it works for my drafty old house, it'll work even better for yours. I'm going to come back to Flux because it's honestly the thing that makes the battery worth having. But first, let me show you the numbers. Here's my full 2025 from the Octopus app. Right away, 2 things jump out. First, gas is 62% of my total energy bill. Solar panels don't heat my house. They don't heat my water. If you're thinking solar will slash your total energy costs in half, it won't. Not unless you've got a heat pump, which I don't. Gas is still the big one. Second, that £469 in export earnings is real money going back into my account. That's not a feed-in tariff estimate. That's actual credits on my Octopus bill. Okay, so let me explain the Octopus Flux tariff because this is the key to making a battery system actually pay for itself. Look at those peak export numbers. Octopus pays me 29.32p for every kilowatt-hour I export between 4 and 7 p.m. And they charge me 16.37p to import between 2 and 5 a.m. So the battery charges up cheap overnight, and Octopus automatically discharges it at peak time either to power my house or export to the grid. I don't have to do anything. Octopus controls the battery dispatch. I literally set it and forget it. And the numbers prove it works. Look at my November export breakdown. Out of 192 kilowatt-hours exported that month, 115 kilowatt-hours, 60%, went out at the peak rate of 29.32p. That's the battery doing its thing in the most profitable window. Even in November. Even when the panels are barely generating. That earned me £41 in one winter month just from exports. Now, let's look at winter because this is where you really see what solar can and can't do. November to December 2025. I imported 855 kilowatt-hours of electricity. Cost, £234. Export credit, £41. So my net electricity cost was about £193. December to January was worse, £255 import, only £26 back in exports. Less sun, shorter days, more heating. Net electricity, £229. Gas, £339. Total are nearly £570 for 1 month. Winter is hard. Let's not pretend otherwise. The panels generate a fraction of what they do in summer, and the battery can only arbitrage with what it's got. But here's the thing, even in the worst months, the system is still doing something. It's still shaving 7 to 15% off my electricity consumption compared to the year before. And I'm still earning £25 to £40 a month from exports. November to December electricity, 2024 was 917.6 kilowatt-hours, 2025 was 855.1, that's down 7%. December to January, 2024 was 1055.6 kilowatt-hours, 2025 was 894.2, down 15%. Year on year, the system is making a real difference, even in the depths of winter. Okay, I've just shown you winter. Now let me show you what happens when the sun actually comes out. This is my summer bill. June to August 2025. And the numbers are completely different. Let that sink in. £39 a month. Net. For all my electricity. In summer, I'm exporting almost as much as I'm importing. The panels are generating, the battery is doing its flux arbitrage, and I'm getting over £100 back from the grid. Look at that. £131 a month in summer versus £568 in winter. The same house, the same system. The difference is the sun. In summer, I'm importing just 11.6 kilowatt-hours a day, less than half of winter. And I'm exporting 12 kilowatt-hours a day back to the grid. I'm actually putting more electricity out than I'm pulling in. And look, in summer the daytime export is massive. Nearly 500 kilowatt-hours at the day rate because the panels are generating so much surplus during the day. Plus another 177 at peak rate from the battery dispatch. Over £100 earned in 2 months, just from exporting what my roof generates. This is why the annual numbers work out. Summer carries winter. Now, here's where a lot of solar YouTube videos get dishonest. They compare their pre-solar bills to their post-solar bills and go, look how much I saved. But they ignore the fact that energy rates changed. I'm not going to do that. This is my OVO bill from November to December 2022. No solar, no battery. Peak energy crisis. I was paying 33.38p per kilowatt-hour for electricity and 9.81p for gas. See the difference? Electricity was 36% more expensive. Gas was 66% more expensive. Plus, the government was giving everyone £66 a month in energy bill support scheme credits, which are baked into those 2022 bills. So if I just compare raw bills, £676 then versus £460 now, that looks amazing. But a lot of that drop is just rates coming down and the government subsidy disappearing. Let me do a fairer comparison. If I take my 2022 consumption 840 kilowatt-hours and price it at today's rates, that'd be roughly £220. My actual net cost with solar in 2025 was £193. So the true solar saving in the worst month of the year, rate adjusted, apples to apples, is about £25 to £30. Not life-changing in winter. But remember, summer is a completely different story. That's where the £469 annual export mostly comes from. Right. The big question. When does this thing pay for itself? I'm going to be honest with you, at the price I paid in 2023, the payback is long. If I'm conservative and say the system saves me about £750 a year total, that's export income plus reduced import, I'm looking at over 20 years. Even optimistically, with energy prices rising and the system saving closer to £1,200 a year, it's still 12 to 15 years. But, and this is a big but, if you're buying today, you'd pay $11,000 to $13,000 for the same system. That's 25 to 35% less than what I paid. At those prices, payback drops to maybe 8 to 10 years with moderate energy price increases. That's a much more sensible proposition. I paid early adopter prices. You don't have to. So who is this for, and who should think twice? Solar makes sense if you own your home and plan to stay at least 8 to 10 years. You've got a southish facing roof with decent space. You're on or can switch to a time-of-use tariff like Octopus Flux. You understand it won't eliminate your gas bill. And you can get a system for under 13 grand installed. And remember, my house is a large, poorly insulated 6-bed detached. If you've got a smaller, more efficient home, your payback will be faster than mine. Think twice if you're renting. Your roof is heavily shaded or north-facing. You're expecting to halve your total energy bill. Gas is still gas. You can't get a time-of-use tariff. The battery loses half its value without arbitrage. Or you're planning to move in the next few years. And look, the honest answer is I probably overpaid. 17 grand was a lot. If I'd waited 2 years, I'd have saved 5 grand on the install. But I also had 2.5 years of exports and savings that I wouldn't have had. Swings and roundabouts. The system works. The battery earns its keep through flux arbitrage. The export income is real. But it's not a magic bullet, and anyone who tells you otherwise is selling something. So that's 2.5 years of real data. No estimates, no projections, just bills. 3.5 grand total energy in 2025. Nearly 500 quid back from exports. And a system that, if you bought it today, would probably pay for itself in under a decade. If you found this useful, hit subscribe. I'll be doing an update at the 3-year mark with a full summer breakdown. And if you've got solar, drop your numbers in the comments. I'd love to see how other systems compare. Thanks for watching. See you in the next one.